Tutorial 3, Part 2, Line Defects. Edge dislocation is defined as an insertion of a plane or a half plane of atoms into a regular lattice structure. You can see from the picture here, the original crystal structure doesn't contain the green atoms, and it shouldn't contain the green atoms in terms of a perfect crystal arrangement. But often it is the case there is an addition of these green atoms, which we call it the plane of the atoms. The dislocation line is defined as the edge of the extra half plane of the edge dislocations. This we call it edge dislocations, those green atoms. And the T shape, which marks the dislocation line, it is quite straightforward and quite intuitive, and you can basically understand how can we draw the symbols. How can we identify those addition of these extra atoms in a crystal? We can use Burgers vector, and which represent the magnitude and the direction of the lattice distortion caused by these dislocations. One example, draw the Burgers vectors for the following edge dislocations. First thing is we need to identify where is the extra plane, and here is the label. Here is the symbol, and the red atom we have marked. I have just marked for you. And then we choose an atom. Draw the Burgers circuits as move for x atoms. X is an integer. Turn 90 degrees, and then move for xs atoms and turn 90 degrees, and repeat the process for 2 times. The direction should be clockwise, and the such circuit should surround the dislocation line well away from dislocation position. And the Burgers vector B, which is here, the red arrow, will be from the end point to the start point of the Burgers circuit. The Burgers circuit is the steps we draw from step 3, which we call it Burgers circuit, and which is the black arrow. In this case, we choose 5 atoms, and it is first moved 5 atoms to here, and then 5 atoms to here, and then 5 atoms to here, and then 5 atoms to here. And the Burgers vector is basically these red vectors. Screw dislocation. Screw dislocations is different from edge dislocations, which is a shifting of an upper portion relative to the lower portion in usually 1 atomic distance by shearing stress, and you can observe it here in this picture. Normally, this region should at the same plane with this region. And however, there is a formation of the edge, not a screw dislocation in this piece of materials. I also draw a Burgers vector on screw dislocations. Draw the Burgers vectors and determine it is the left or right hand screw. We draw the Burgers circuit first with a similar step mentioned for edge dislocations. Notice that this time it is again clockwise, and Burgers vector from start point to end point. The Burgers vector must be at this plane. Remember that. Again, it is, but this time it is from start point to end point. It has a different orientation with the edge dislocations. Using the right hand rule, clockwise will represent a downward direction, which is mentioned by right-hand rule. And that means the screw itself, it is a right-hand screw. If it is in opposite direction, definitely it is a left-hand screw. In real cases, screw and edge dislocations are often both exist, and pure screw or edge dislocations are rare.